I assure you, it is a matter of utmost importance, Prince Zuko.
Is it something to do with the Avatar?
Even more urgent. It seems I've lost my lotus tile.
Our team's primary goal was to melt aluminum scrap metal and cast coins and other objects. The first step in this process was to draft a 3D CAD model of a coin, in our case, a White Lotus Pai Sho coin from the beloved Uncle Iroh of Nickelodeon's early 2000s hit Avatar: The Last Airbender.
The guest has the first move. I see you favor the White Lotus gambit.
Once the CAD model was complete, we printed the casting mold on a Dremel 3D printer. The next step was to melt the aluminum in a foundry. Conveniently enough, the fabrication lab assistant knew where we could find one. The scrap metal came from the god himself, Zach Shockley's place of employment, Bob Hunt Machine Shop.
Oh, baby. Yes. Come over here, look. It's getting so close.
Wowie.
Zooey mama.
Look at that. Good old Zach. Going for a dumpster dive, I guess.
The foundry worked by blowing compressed air into a spout that ran through the bottom and fed the burning coals above. Aluminum has a melting point of 1220 degrees Fahrenheit.
So one of the things I'm wanting to do when I'm layering this charcoal is basically angle it to where you're able to still put in the crucible to where it gets hot, but you're not messing up the integrity of the charcoal that's in there.
The constant supply of air allowed the coals to burn much hotter than your typical backyard barbecue and concentrated the heat on the crucible located in the center.
So now we're gonna, once the charcoal starts getting heated, we're gonna add the crucible in. We're gonna let it sit there while we let it heat up. Should take a little while. All right, we're gonna try our first can of delicious Miller Lite. Let's see what happens.
Depending on the size of the scrap aluminum we were using, the melting time ranged from 5 to 25 minutes. Once the aluminum was melted, we brought it to the sand molds for casting.
What a beautiful sight.
Wow.
We're gonna let the fumes sit off and then you'll see it turn into metal. We kind of want some slag with it, mainly just because the slag allows us to pour it out of one thin hole. You're able to poke a hole in the slag.
The sand casting molds consisted of a mixture of 90% aquarium sand, 10% bentonite clay in the form of a powder marketed as a face mask, and a small portion of water carefully mixed together to create a consistency that allowed the sand to clump and hold its shape.
Oh, what you doing here?
So I'm mixing 90% aquarium sand, 10% bentonite clay, and a little bit of water to make this like clumping sand formula. And then this is about 4 pounds of it. I got about 12 pounds in there. I'm gonna pack it in tight to the box outside and press our objects into it and hope that it comes out as a nice mold to pour into. The molds were pressed into the sand using the 3D printed coins and various objects we had lying around our apartments, including shot glasses, badges, and the bottom of a classic city lager mug that Zach had acquired from Cutter's downtown for a remarkable price. The first cast was created using 3D printed White Lotus coins. We pressed them into the sand so that their design was imprinted into the surface and poured the metal from the crucible into the molds. They were allowed to sit for 5 minutes and then removed with tongs and placed into a bucket of cold water to cool. With more accurate dimensions and measurements, we could have used Chauvinov's rule in order to determine the appropriate cooling time for the casts, but the design and viscosity of the metal created unpredictable thicknesses, so we overestimated the cooling time. We followed these steps with each of the other objects until we felt that we had adequately demonstrated the process.
Hey, let's go pour some metal, you know? We got the sand molds playing over there. It's our first attempt, so hopefully things go well. I'm gonna grab the cauldron, I got the gloves on. We're gonna get moving over there. Alrighty, let's grab this bad boy. Let's get moving.
One lesson we learned throughout this process was that fine details were lost throughout the sand casting process, and to solve this, more pronounced details on the casting mold are necessary. While our 3D printed coins came out clean and detailed, the difference in depth were too slight to show up clearly in the sand and did not turn out well in the final product due to the metal's high viscosity and unwillingness to sink into the small indentions. We also learned how much fuel the foundry and smelting process use as we ran out of charcoal halfway through and were forced to buy more. This is another reason why efficient smelting times were important. Another lesson we learned was the efficiency of using small scraps of aluminum instead of large chunks. This exposed more surface area to the crucible and its heat, shortening the melting time from 25 minutes to 5 minutes.
So it seems that we might have had a problem. This aluminum beam has been sitting out in the cold. I think it's 45 today. As cold as this is, when I put it in, it ended up solidifying. With this aluminum piece, we're gonna have to cut it into bite-sized pieces.
Making a shot glass.
Becky's over here pressing in the new shot glass. Still very hot, but we're gonna be able to get her out. Oh baby, look at that shot glass.
In conclusion, the smelting and casting process offers a wide degree of form freedom, but at the cost of detail and surface finish. We learned a lot about the variance between smelting and cooling times, as well as the importance of our friendship and companionship.
Most people think the Lotus tile insignificant, but it is essential for the unusual strategy that I employ.
You've changed our course for a stupid Lotus tile?